in this example, we have a couple of chair cyclohexanes that we want to figure out the relationship between. And even for me that's been doing this for a long time, it's hard to just look at these and immediately figure out the relationship. So for me, it's a lot easier to just quickly convert these into the flat cyclohexanes with dashes and wedges. So let's do that first. Let's start with this one. Find yourself a spot to orient. So I'm going to say this carbon is this carbon on my flat cyclohexane. And we're going to number, just to keep track of things, I'm going to number clockwise. And make sure you keep your numbering clockwise on your other ring. Okay, now draw your groups in. Okay, on carbon 1, the OH is pointed down. So let's make that a back group on the ring, pointed back. So translate your down group to back. Okay, on carbon 3, we have a methyl group, and its net direction is upward. So on carbon 3 of our flat cyclohexane, let's make that an out group, or a wedge. So translate your up group to out. Okay, so we've done that chair. Let's do our other one. Okay, let's try to be consistent here. So the carbon with the OH, I'll put that right there. Number around your ring, I want to stick with the clockwise numbering. Okay, carbon 1, we have this equatorial OH that's pointed up, which means on our ring we want to make it out. So the up goes to out. On carbon 3, we have this methyl group. It's pointed down. So in 3, we want to make that a back group. Now that we have the flat cyclohexanes, they're easy to compare. And we have the rings oriented in the exact same position so that, carbon 1 is the top right carbon of the ring, carbon 4 is the bottom left carbon of the ring. So as long as your rings are oriented in the same spots, they're very easy to compare. And the chiral center at 1 was inverted from back to out. The chiral center at 3 was inverted. So all the chiral centers in the molecule have been inverted, or just say both chiral centers. If that's the case, we have a pair of enantiomers. If you want to prove that this is, the second compound's a mirror image of the first, okay, think about taking this second compound and flipping it over 180 degrees horizontally. Essentially, you're going to flip it so that this carbon 1 comes to the left side, carbon 4 to the right. There's 1, 4, and 180-degree flip. Remember that something that's out, like the OH, if you flip it 180 degrees, it'll end up back. The methyl and carbon 3, it was back. It'll end up out. So now if you compare this drawing to this drawing, you can see that there's a mirror plane between those to further prove that they are, in fact, enantiomers.